Hey everyone, this is Mr. Huff. This is going to be part 3.
And Miss McConnell's here as well.
Um, okay, so for whatever reason, people mess this up. It's R of x is defined for you here. P of x over Q of x. P of x and Q of x are also listed for you. All you had to do here was set them over each other. So we have x plus 3 over x times x plus 3 times x minus 3 quantity squared. Okay, you don't even need a calculator to analyze any of the other stuff. Right, everything is right here, all you need. So, if we want to just quickly, we can simplify this too, so that we don't even have to go for when we start talking about some of this analysis. Good.
The first thing you really want to do, though, because of this simplification, this actually highlights the need for this, is you want to identify your domain. So before you talk about vertical asymptotes and holes, those are different parts of domain restrictions. You need to identify first and foremost that your domain is all real numbers except, that symbol means all real numbers, except x cannot equal 0, -3, or 3. And your task in your analysis is to then determine which parts of your domain are going to be affected on your graph in which way. So is your domain restriction going to produce an asymptote, meaning that as you approach a value, let's say that this x value is some number c. So if it's a vertical asymptote, then as you approach that asymptote from the right-hand side, and as you approach that asymptote from the left-hand side, which sometimes you will see this written as c, or as x approaches c from the right-hand side, right, the positive direction, and as x approaches c from the negative direction. You didn't have to know that part, but this is just for you. But if it's a vertical asymptote, then your y values better be either approaching a positive infinity or negative infinity. And that is extremely important. Versus if you are looking at a hole, then what's going to happen is as you approach this x value from the right, and as you approach this x value from the left-hand side, then you'll see that it's going to the same y value. So you need to identify which one is which.
Okay. So with this restriction, or with this simplification of this original R of x function, hopefully you see that this x plus 3 and x plus 3 over x plus 3 divide, since they are a form of 1, leaving us with x and x minus 3 quantities squared. So you basically what we want to know is which values of x, 0, -3, or 3, are going to give us 0 in the denominator. 1 divided by 0, not a good time. We don't want any division of 0. We don't know how to deal with it. So if we set these equal to 0, now this is the thing called the zero product property. If x is equal to 0, the whole thing is equal to 0. If there's an x value that makes this factor 0, then the whole thing is equal to 0. So we're trying to identify which x values a part of this product are going to give us 0. So in this case, x is equal to 0, or x minus 3 squared is equal to 0. Well, this is done. X equals 0, we don't even have to do anything. Now, notice if we square root both of these, we end up just with x minus 3 is equal to 0. And so x is equal to 3. Now, these are the x values that we cannot use. Purple. 0 and 3 are going to be our asymptotes. So we have vertical asymptotes at x equals 0 and x equals 3. If you just left it like this, we would have to kind of read into what you said, but it would be really clear for you to say x equals 0 and 3 are vertical asymptotes or something like that, so that we know definitively, like, you know exactly what you were solving for.
Some students specifically explicitly mentioned, because these are values in our denominator that don't divide out, and so that's going to cause the vertical asymptotes. And just a note here that if you plugged in something like 3.001 to your equation, you would start to notice those y values would be tending to either infinity or negative infinity, because you would get really large positive or negative y values depending on if you did 2.999 or 3.001, or similarly you could do negative 0.0001 or 0.0001, something close to those values. Yeah.
Now, for the whole, you might want to say, well, the process of elimination tells us that x equals -3 would have to be the whole, and you might be prompted to do something like this. That tells me nothing. That tells us nothing. We want you to explain how you solved using the equation. In other words, you should not use your calculator, your graphing calculator, or the graph that it generates. So if you said x equals -3, then I needed some sort of narrative about how x equals -3 is not a part of the domain. Being in the denominator, it would give us a 0 here, and that would break the fraction. But in the simplified form, it appears that we can use x equals -3.
In fact, if you used your calculator's graph, it probably wouldn't have even looked different there unless you had a really advanced calculator.
And so basically what this is telling us is, as x goes to -3 from both sides, left and right, we approach some y value. You could have put -3 right into this simplified form to figure out what y value it would have been approaching. So -3 minus 3 is -6 squared.
36 times
3.
-3, so 108, -108.
-108. So this is the value that your y value that it would have been approaching.
1 over -108.
Oh yeah, 1 over. And so you'd have a whole at this value. Basically, if you picked some values really close, like what we were doing over here,
in your original function,
you would get this output. It would be approaching that particular output from both sides. Whereas if you were doing that same idea here, you would see that the values were taking off to positive or negative infinity.
Now, of course, you would actually want to show that work. You would actually want to show that you substitute -3 into this equation, since you don't have the oral explanation that we are giving you here. So you would want to make sure you show the substitution, and then you'd want to write your answer as a coordinate. So -3, comma, -1 over 108 would be the most appropriate answer for that.
Now, so let's see. Now, x-intercepts. So an x-intercept, if we think about what that is basically is whenever y is equal to 0. So we get x plus 3 over x times x plus 3 times x minus 3 squared. If you notice, if I multiply this denominator over to the other side, I just get left with 0 is equal to x plus 3. And so then I get x is equal to -3. But if you notice, this x equals -3 is our whole, which means that it's been punched, that we don't get a value at x equals -3. So we're never going to actually cross anywhere. And so that would be finished there. Y-intercepts. That's when our x's are 0. But if we notice here, we have x equals 0 as a vertical asymptote. We know if we approach from the left and the right, that particular asymptote, it's going to tend to positive and negative infinity. So in this case, we won't actually get any y-intercept because we have a vertical asymptote at 0. So no y-intercepts since we have a vertical asymptote at x equals 0. That would be sufficient.
You could also show that you calculated r of 0 and that you substitute 0 in for your x values and that you end up with either 3 over 0 if you used the first equation or 1 over 0 if you used that simplified equation.
Which we know won't do anything for us. And so we would be done there. So then the end behavior, notice that we have a single power in the numerator, a smaller degreed function in the numerator, and a larger degreed function in the denominator. So this should tell you that we have a horizontal asymptote that is at y equals 0. And so our end behavior is as x goes to negative infinity, y is going to go to 0. And as x goes to positive infinity, y will then also go to 0 because we have a horizontal asymptote at y equals 0.
And of course, a really clear indication of this is if you start substituting larger and larger values for x, you'll see that this function on the bottom, which is a cubic function, of course is going to end up overtaking this measly linear function up here. And it becomes even clearer when you look at the simplified version, which is 1. And then you're going to be taking 1 divided by really, really large positive values or really, really large negative values. So you could kind of imagine 1 divided by even 1,000 is really close to 0. So that will also give you your horizontal asymptotes. So that's just a little bit about what we were expecting. We've decided not to grade this problem because it was clear with the majority of the class that you were assessed too soon on it. Now, what that means is that you need to accept responsibility to go and learn this further and deeper. And we are open for questions as well as any tutors could help you with this. But it's really, really important that you understand rational functions because this kind of analysis is really important in calculus and it's also going to be on your final. And we might even bring it up on a concept check in the future just to make sure that you have been studying this. So that's it. We hope you have a wonderful rest of your day.
Yep.